Hi, my name is Amy Cheng, and I'm a web developer from the Brooklyn Museum of Art in New York City. And today I'm going to talk about using JavaScript to create drawings, animations, and infographics. When I refer to drawings, I mean graphics rendered dynamically in the browser. Another thing. I know the title says infographics, but what I meant to say was data visualizations, which is like way cooler than infographics. An infographic is just like in the newspaper, they would show like a skyscraper, and then they would like put tick marks along the skyscraper to talk about, you know, skyscraper heights. That's not what we're doing. We're doing something way more, we're gonna go over things way more cooler than that. So once again, drawings, graphics rendered dynamically in the browser. I believe that JavaScript is a legitimate way to create visuals for the web. I also believe that programming can be a great tool for design, for doing design and art for the web and beyond. And this was I kind of affirmed this to myself when I was learning computer programming formally. For the most part, I'm a web developer and I'm mostly self-taught, and I was mostly self-taught. When I was 13, I just figured out how to use JavaScript to make I had a Star Wars fan site, so I used JavaScript to create an image map and an MIDI player in the background. And it wasn't until 10 years later that I actually took a computer science course to learn the sort of formal topics of computer science. So in this programming course, we use a language called processing. How many of you have heard of it? Wow. So processing is kind of like a subset of Java. The thing about processing that it came out of the MIT Media Lab, and it was a programming language designed for artists and designers. So while I was learning programming concepts like arrays, lookup tables, object-oriented programming, I was also making these little art pieces. Like, for example, I made this interactive mirror thing. I made a game with abstract symbols on the screen. And in order to run these things, you either had to run it in the processing internal development environment, or you had to compile a Java executable. Now, since then, JavaScript has evolved to the point where you can run all that stuff in the browser. So in today's presentation, I'm gonna go over really quickly about some of the tools that we can use to create visuals for the web. I'm gonna go over P5.JS, RAPHAEL.JS, D3.JS, and THREE.JS. P5.JS and RAPHAEL.JS are general purpose drawing frameworks. D3.JS is more oriented towards data visualizations and mapping. By mapping, I mean geographic maps. THREE.JS is more towards 3D animation. So why use JavaScript at all? Well, the obvious reason is you don't need to rely on third-party plugins. So you don't need Flash embeds, and it's one less step for the end user to further engage with your website. Plus, instead of learning another language or hiring someone, or hiring a Flash developer or a Unity developer. Is anyone familiar with Unity? Okay, so Unity is this, it's kind of it's becoming this go-to game development platform, and you can compile to iOS, Wii, PlayStation, but also to the web. So I've been seeing this a lot. There are some web games that actually use Unity as a plugin. And you probably already know the right amount of JavaScript to get started. You can extend your knowledge to drawing and creating data visualizations. I mean, you use JavaScript to handle button clicks, carousels, parallax scrolls, so why not use it to generate moving circles or interactive bar charts? Also, when you use JavaScript to draw things for the web, you're taking advantage of the interactivity and extensibility of JavaScript. For example, let's say you want to show a data visualization related to someone's location. In maybe 10 years ago, you'd have to ask the user to input their location. But nowadays, you can use JavaScript to sort of detect their IP address. And then from that information, just generate a data visualization based on their location gathered from their IP address. Also, you can do something where each time a user visits your page to get a whole new movie. Also, with JavaScript, you can tie into things like get user media. How many people are familiar with that HTML5 API? Okay, so get user media allows websites to access the user's webcam or microphone. 10 years ago, you had to use Flash to do that, but now you can actually use native JavaScript, assuming that your users have a modern enough browser. Also, if you use JavaScript, you can like contribute to better developer quality of life, which I think when it comes to project specs, a lot of project planners underestimate how developers' quality of life affects the project. So instead of having to deal with a third-party code base, you can use JavaScript for everything. It's more legible to other developers who already know JavaScript. And using JavaScript for everything helps to reduce technical debt. Of course, this is assuming that your team members like using JavaScript. I'm sure there are some people who just absolutely hate it. Now, even though for the most part, we're going to go over some frameworks, you don't need a framework to draw to the web. You can use the HTML5 API Canvas, and P5.js and THREE.JS actually use the Canvas element as their base. The Canvas, you can think of the Canvas element as a container for bitmap drawings on a website. So if you look at the source code of a website that uses the Canvas element, you'll see just the Canvas element, but none of the things you drew to it. We'll go over more of this later. By the way, Canvas is supported by all browsers and devices except for IE8 and under. So if you have to support for IE8 and less, you're kind of out of luck. But we'll go over fallbacks for that. So let's draw a circle. So feel free to take out your laptops. A note, this is not actually JavaScript. This is a GIF, because I did not want to slow down the computer with several of these things going on. So we want to write our markup pretty easy. Just use the canvas tag, give it an ID. It's probably not best practice to also call it canvas, but for demonstration purposes, I also called it canvas. And so you want to reference your canvas in your code. Here we're setting a width and height that we'll refer to later. We want to reference our canvas, and that is what we're doing in document.getElementById. And then in the last line, we're setting the context. Basically, what that line does, it's telling the browser, hey, I'm about to create a two-dimensional drawing. You can also use the canvas element to do 3D, but instead of passing in the 3D parameter, you're telling it you're going to put in WEBGL, and that tells the browser to utilize your GPU, graphic processing card thing, to create your drawing. CTX is the actual graphic that we're going to try to render. So next, let's draw our circle. The first line is telling the computer, hey, I'm about to begin drawings. So picture the Canvas API as your pencil. First line, hey, I'm setting my pencil to the paper being your web page, or the DOM. DOM stands for Document Object Model, and it's basically the blueprint for your browser to render a web page. The second line, we're telling the browser, hey, I'm about to draw this type of line, an arc. The first parameter is the X position, and the second parameter is the Y position. The X and Y actually refer to the center of the circle. The next one, 50, is our radius, and the last two parameters, 0 and 2 times math.pi, actually refer to the start angle and the end angle. So the last parameter resolves to 360. So we're telling the browser to go 0 to 360, essentially creating a circle. The last line is telling the browser to create a stroke. Basically, hey, I actually want this to show up on the website, and I'm done. So let's animate the circle. We want to set the initial properties, so this is where we want our circle to begin. The direction and speed will affect how many pixels the circle's center will move along the screen. Then we want to create this draw function. So this draw function is going to run every few milliseconds, and it's going to continue running on loop. We're going to use something called request animation frame, which is another HTML5 API. So request animation frame is like set interval, which basically allows the browser to continually run a function. The difference between set interval and request animation frame is that request animation frame is for animations, and it's a lot smoother than set interval. It'll run, but it will not run the next function until the first function has resolved. And also, with request animation frame, your function will not run if the web page is not the current tab in your browser, which really saves on processing time. Whereas with set interval, I think it just keeps going whether or not that's your active tab. So let's go over our code. So here's our draw function. Oh, another thing is we're passing it in here, but within the draw function, we're calling back request animation frame. So that's how the looping happens. So the first line, we're setting a clear rectangle, and I'll go over that later. We have our usual, this is all the code we did before, where we were drawing our circle. Then here we have some conditionals. The first conditional, if the X position is 450 pixels, remember the width of our canvas element is 500 pixels. We set it right here. So basically in this conditional, if the circle's center is at 450 pixels, change direction. And if it's at 50 pixels, which is the left side of our rectangle, go in the other direction. And so it'll go back and forth. Here's our final code. Now, remember we had clear rectangle? That is because we want to clear the background during each animation loop, and if we don't, we get this, which you might want, but most often you probably don't want a transparent background. Oh, a gotcha with the canvas element. You can use CSS to add a border to the canvas element, but if you use CSS to resize the canvas element, it will actually stretch out your animation. So if you want to dynamically set the height and width, you'd have to set the attribute instead of applying a style. But why should you use a framework? Well, you have syntactic sugar, which you'll see later on, code organization, and developer quality of life. If your code is organized and it's not just like a wall of text like this, oops, your team members will probably be happier. So the first framework we're going to go over is P5.js, and it's self-titled as a software sketchbook. So here is an example of an animation done with P5.js. This is a flocking demo. So each dot has its own behavior, and that behavior is influenced by its neighbors. So what's happening here is each dot sets off in a random course of movement. But then it's like, well, I want to kind of be close to my neighbor, so it goes towards its nearest neighbor, and it's doing this in an array. So there's an array, and in this array are all these dots. And during each runtime, each dot looks to see where its nearest neighbor is. But it goes towards its nearest neighbor but it goes towards its nearest neighbor, but avoids bumping into its neighbor. So there's some collision detection going on, and so it's going towards its nearest neighbor, and there's collision detection, and this results in flocking behavior. And flocking behavior occurs in nature. You see it in birds, you see it in schools of fish. This is all done, I know it says .php, but this is all done in JavaScript. So P5.js is a spiritual descendant of processing. As I mentioned before, processing is built on top of Java, and it was designed with designers and artists in mind at MIT Media Lab. It's a programming language for artists and a way of making art for programmers. And one of the goals of processing is making it accessible. So there's an ellipse function. So when you want to draw a circle or a sphere, you use an ellipse function instead of .arc, which we saw in the section about the Canvas API. And because of this, processing is great for education. A flavor of processing.js, which is like 100% direct port of processing to JavaScript, is used on the Khan Academy website. How many people are familiar with Khan Academy? So Khan Academy is this kind of like online learning platform. They have sections on science and math, and they also have a section on computer programming, and they use processing.js to illustrate concepts. Now, P5.js is a fairly new and untested framework. It's at 0.15, I think, and I'm presenting this framework regardless of that because it's based off of processing, and it'll one day, I think the goals of the developers behind P5.js wants P5.js to have all of the processing methods, but also the drawing idioms that are used in the processing language have proved to be a great introduction to people wanting to learn computer science, and people who begin with processing actually continue learning more about computer programming. I mean, for myself, processing has served as like a gateway programming language, and now I know JavaScript. It kind of set me up for understanding like languages like Rails and C++. And I think P5.js offers an opportunity for you to collaborate with non-developers. Because the methods are more legible to like lay people and the drawing idioms are fairly easy to understand, you can actually bring designers in to your team. And I feel like you would get better ideas for your project if you collaborate with non-developers, because as a developer, I know for myself, I just tend to be pretty insular. I'm like, I'm just going to ignore the designer. I'm not going to bring them in until the end. And then they're like, wait a minute, I don't understand what you just did. I mean, how many people have like come across that situation where they're just like, go straight on ahead and just kind of collaborate after when it's a little too late. So P5.js has two very important functions, setup and draw. The setup function only runs once. It's not best practice to have it run in set interval or window request frame animation. And this is where people usually set up their initial parameters for an animation. Then we have a draw function which runs continuously. I suspect internally the draw function is just like a shortcut method for window.requestFrame animation, but I'm not entirely sure. So this draw function runs approximately about 30 times per second, and you can actually set how often it runs by using the method called .framerate. So let's draw our circle again. Here we have create canvas, and we're setting a width and height of 500 and 400. Create canvas actually appends the canvas element to our DOM. Then we're setting our background to white, which is 255. So this numbers, the color space for P5.js goes from 0 to 255, 0 being black and 255 being white, and you'll use 0 to 255 to set red, green, blue channels if you ever want to set a color. Here we have an ellipse, so we're drawing a circle whose center starts at 0. So it's 0, so it's lying on the left edge of our canvas. 200 pixels from the top, has a horizontal radius of 50 and a vertical radius of 50. So let's animate our circle. Here are some variables. We want to refactor our setup function. So instead of dumping this stuff here, we just have create canvas and background. Then we're creating our draw function. This is where we're actually drawing our circle, and we're gonna actually draw it repeatedly, but each time we draw the circle, we're resetting our background to white. Totally forgot I had my laser pointer. Then we have our conditionals. And I wanted to show this particle system demo because I think this really demonstrates the power of JavaScript, and you can actually do a lot with the number of methods that P5.js have. Their reference is just like one page. So a particle system physics is found a lot in video games actually, because each time you see water or fire or clouds, most often the computer programmers use a particle system to render those things. So what's happening here is that we have a particle system object and then particles. In our particle system object is really just an array that we're going to put our particles in. Then we want to add particles to our particle system. So each draw loop, we're adding a particle, and we're also telling the particle system to go forth and run. So we're adding a particle towards the end. In our particle object, each particle object has its own acceleration, velocity, position, and a lifespan. This lifespan is actually important because if we just keep adding particles to our canvas, the browser is going to eventually run out of steam and crash. So what this lifespan does is, like, once it reaches its 255th draw loop, the particle object will get will actually go back to the top, and then the particle system knows to stop adding particles. Event handlers. So for those who know JavaScript, so you can bind event handlers to DOM elements, but not so in P5.js. Instead, event handlers are their own functions. Now, the design decision for this was to make it more accessible to people who might not understand event binding. So this is a small art thing that I made with P5.js. The logic is all in the detect quad function. Here I'm setting a background to be all white, but I've done it this way because I wanted access to the alpha channel, which is the 4th parameter. So each time the draw loop runs, we have this nice fading effect. Then we have the stroke, which refers to the color of the line, which refers to the line that is being drawn. Oh, actually, sorry. The stroke function here actually is setting the color. So here I have random, 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 but I have the green channel set to 0. So what this code is doing, it's creating a random pink purple color. I mean, a random color from the pink purple end of the spectrum. Then we have lines. Mouse X and mouse Y is provided by the mouse drag. That's just a global variable that P5.js exposes to your code, and it just refers to the XY position of your mouse cursor. So each time the mouse is dragged, detect quad runs. Next framework that I'm going to talk about is RAPHAEL.JS, and it's described as a JavaScript library for vector graphics. So RAPHAEL.JS creates SVG elements. So SVG is an XML. How many people know what SVG is? Okay, so I'll speed through. So SVG is a XML based file format, and it uses math data to render graphics versus pixel data, which is what you get from bitmap graphics. The Canvas API renders bitmap. So the difference between SVG and using a Canvas element is the difference between using a pen and a pencil, which becomes important if you're drawing for mobile devices that have high pixel density displays. A Canvas drawing might not look that awesome on a Retina display, whereas SVG might still look crisp. So here's a super awesome tiger created with RAPHAEL.JS. And here's the source code. So it's just like a bunch of coordinates. But since it's in the DOM, it means that you can bind events to it, which you couldn't do with Canvas. And it's also more accessible to screen readers because a screen reader can actually see this code. Whereas if a screen reader, and so since it sees this code, it can also see alt text if you have described alt text in your code. And it also means that instead of just seeing a Canvas tag, a screen reader will see alt text. This was a drawing, but since you're a screen reader, you can't see it. Also, SVG has better compatibility for more browsers. I had a project in 2011 where I wanted to do like dynamically generated bar graphs, and I so wanted to use the Canvas element, but we had to support IE6, so I just had to like use RAPHAEL.JS and render a bunch of like SVG elements. I mean, it did the job, but it wasn't as elegant as I wanted it to be. So differences from P5.js. SVG, instead of using Canvas element, it uses an animate function instead of the draw function. So let's draw our circle for the third time. We want to initialize RAPHAEL in our code. And that's happening in the second line. Then we're drawing our circle. RAPHAEL.JS has a circle function. X position of y, x position of y, y position of 200, and a radius of 50. Here we're setting attributes: fill to white, a stroke of black. Now you can also accomplish this with CSS classes. So if you created this drawing, you can use CSS to, if you created this drawing using RAPHAEL.JS and all those SVG elements are on the DOM, you can use CSS to like make this tiger purple if you wanted. So let's animate our circle again. For those keeping track, this is the third time that we've drawn and animated this circle. Nature of JavaScript, right? Multiple ways to do one thing. So this will look familiar to those who have used jQuery. It's very, very similar to the animate function in jQuery. We want to set its target property. So here we want the circle to end up at 0. We want it to take 2,000 milliseconds, so 2 seconds to get there. linear tweening, which is how it steps towards that position, and the callback function. So after left is done, run right. And so we define the right function, setting left as its callback, and then we finally call right, and this creates a loop. So this is what's happening in our source code when animate is running.
How does it affect the performance?
It really depends how many elements there are, but in some cases, it'll run as fast as Canvas, but in others it might run really slow just because you're directly manipulating the page. And if you have a lot of stuff going on where you're changing your web page, it might get bogged down. Oh, a gotcha for RAPHAEL.JS. If you do not set the attributes here, your circle will be invisible. So remember to always like set the color and stroke. D3.js, call data-driven documents. By data-driven documents, they mean, well, they actually refer to how with D3.js you can bind numerical data to DOM elements. So a div on your web page, D3.js might see that div as representing a data point from your data set. Now, D3.js is a great tool for presenting quantitative data in a more compelling way than instead of a table. People use D3.js to create data visualizations and also to map things. Data visualizations can become very complex, and D3 helps to manage that complexity. And it's also great for dynamic data or large data sets. So if you're using WebSockets to get data from the API and you're refreshing every few milliseconds, D3.js is great for that. Just want to show a few examples. Okay. So City Bike Explorer. City Bike is a bicycle sharing program in New York City, and this Explorer is a dashboard, and it's completely rendered using D3.js, and it lets you look at all the bicycle rentals through the lens of several demographics. So you can look at ride duration, the rider's age. Here we have a data visualization from The Guardian. So this data visualization looks at how measles could spread in certain populations in the US. So I don't know if you guys have heard about it, but in the US there's an anti-vaccine movement. And The Guardian just showed this to show how kind of ridiculous that movement is. What I like about this example is that there's also animations. So as you scroll down, you can see people getting infected as you're looking through the data visualization. You can sort of like get a sense of how quickly measles could spread. Here is the Hip Hop Almanac. Now this is a data visualization I did using ProtoViz, which came before D3.js, but D3.js is based heavily on ProtoViz, and they have the same developers. So D3.js builds on the ideas and design patterns of ProtoViz. I did this while I was an intern for this artist. So the artist I was working with had compiled lots and lots of linguistic data from hip-hop lyrics across several years from different artists. And he tasked me for finding a way to make this data compelling. So I used ProtoViz to create this graph, which looks at 50 Cent's career. You can tell at a glance like how many syllables, word count, sentence counts he's used. I don't know what's going on here, but early on he apparently had a lot of complete sentences in his songs. And this is actually was presented at the Talk to Me exhibit at the Museum of Modern Art. Now, you could avoid using D3.js. You could rely on P5.js or use Canvas, but D3.js is like a huge toolbox and has all these functions, methods, conventions to make you more productive when you're creating a data visualization. There are a number of methods for importing several file types into your code. There are built-in color palettes, so you don't need to spend time thinking about, oh my god, what color should this pie slice be? Animation functions, map building. You can create a map of the world without having to rely on Google Maps. But you do need, however, GeoJSON data, which is a JSON file format, but specific for geographical data. Time parsing, sorry for the typo. If you work with JavaScript, you know how exceptionally difficult it can be to use to like just figure out what date is, or just to like change one date format to another kind of date format. And D3.js makes it a little bit easier. There are also built-in layouts, like pie charts, bubble charts, tree diagrams. So all you have to do is just plug in your data set. So this is a D3.js code sketch, and it'll also look familiar to people who have used jQuery. So it has chaining. Uses SVG, so this is from the City Bike Explorer. This is the source code that's generated by D3. As I said, you can import data from a number of spreadsheet file formats, CSV, JSON, a file format called TSV, plain text files. You can also do exploratory statistics. So imagine you have an array of some numbers. You can quickly find the maximum value from your array. You can also find the average. Data sorting, so you can sort your array in ascending, descending order. So let's make a bar graph. We want to initialize our data. So here we have an array full of JSON objects. But what we really want to map is the count over here. And that is what the map function is doing. So we're spitting out a data object that just have counts. Then we want to map our data to pixels. So we were drawing a bar graph, but we don't want Monday to be 3 pixels high because that's really, really tiny. So we're telling D3, I want to map from 0 to the maximum value, 9, but I want to map it across 0 and a chart height of, well, I'll say it later. Let's say 100 pixels or 500 pixels. Here we're initializing our bars. So we're telling D3 to target our canvas element, not our canvas element. This is why you don't want to name your canvas also canvas. We want to target the thing we've called canvas. We're setting the height and width. Then we have something called select all and enter. So select all is trying to find all of the G tags. G, I think, stands for graphic in SVG parlance. But if G does not exist, what the enter function does, it creates placeholder DOM elements for DOM elements that have not been created yet. This data function, we're mapping our data, we're binding our data here to these G elements. Then we're appending it to our DOM. So here we're setting the XY position according to D. Now D is being returned by this data function. That's not very clear, but that's just how D3 is. Width is like, let's make all the bars 20 pixels wide, and the height, we're looking at the D value. If the height, oh, that's a debugger statement, then we're returning the height. So we have a function called calcHeight, which calculates the height depending on the data variable. And so what this function is doing, it's actually subtracting it from the top. So if you don't have a method it'll just draw the bars coming off from the top, but what we wanted was something coming from the horizontal axis. Label values. So we're appending a text SVG element to each of our bars, saying the text size and the text color, and the text is coming from our count. Now you'll notice that D is all over the place. D is, as I said, is being returned from the data function. D3 has methods for creating a vertical and horizontal axis, and it will also determine ticks automatically, so you don't need to figure out the math for that. So that was making a bar graph. So let's make a pie graph. As I said before, D3.js has layouts included where all you have to do is really plug in your data set. But what layouts are just a series of transformations. So here we're using a pie graph layout. I wish we had internet so I can actually run through this. So picture this, if you will. So a pie graph, everyone knows what a pie graph is. So in a pie graph, you have slices, and each slice is either bigger or smaller depending on the data point that it represents. Now, how would you calculate that arc? Anyone know? Well, you don't need to know because D3 figures it out for you. And so it just automatically figures out the length of the arc, and then all you have to do is set all you have to do is set the color and the stroke, the color of the line. But what color do you want to make the pie graph? You don't need to know that either because D3.js will just give you one. So there are methods in D3 where it's like, okay, hey D3, I have 10 distinct categories. What color should these 10 distinct categories be? And D3.js will give you 10 different colors, and they're all contrasting too, which means there'll be, each color won't be from this, you won't have like two blues. You have a completely different color for each category. Another thing about D3.js is that the learning curve is a bit steep. It's because there's a lot of stuff that goes into a data visualization. For example, for that bar graph, we had to like figure out the height, we had to figure out the spacing, and we needed to create labels, and we wanted to create axes, and that would have been way more difficult if we had used something like P5.js or just even native JavaScript using the canvas element. D3 has all those methods built in, and the learning curve is steep because you have to figure out the right methods to do what you want. And data visualizations can be complex, and so that's why D3.js might seem a bit harder to learn than something like P5.js. But I think it's worth it because it really pares down the difficulty of creating data visualizations, especially as you get better and better at it. So the next framework we're using is THREE.JS, and it makes WEBGL simpler. How many of you are familiar with THREE.JS? Okay, THREE.JS is super awesome because it, instead of like buying a 3D program to do 3D. You can do it all with JavaScript. Someday when browsers and computers get powerful enough, people will probably start making like full-length animated films that you can run in your browser. Now, Three.js is another one of those huge frameworks that it's so huge that people have developed frameworks on top of Three.js. So you'd have like some specialized framework for, let's say, physics, and a dependency would be Three.js. You also see that in D3.js. D3.js is so huge that people have developed frameworks to just create bar graphs because they're like, D3 is so hard to use, let me just make a framework, another framework to make it easier to use. Now, Three.js can also render to SVG, but the developers have recommended on not doing that because doing 3D using SVG elements can really, really bog down the browser and cause it to crash because you're just doing direct manipulations to your web page. And so each time you do a direct manipulation to your web page, the browser has to look through the entire DOM, the entire blueprint, and figure out, okay, so this one thing changed, but how does it affect all these other things on the page? So I'm just going to go through some examples. This is something I did using Three.js. This was actually a 2-week warm-up project in a new job. So this is something called Lights. It is an interactive music video of the song Lights by Ellie Goulding. So as the music is playing, depending on where you move the mouse and how it's traversing those hills, it will change the volume of the music or the cadence and sort of the speed of the music. Here is Find Your Way to Oz. So this was kind of like an interactive 3D movie trailer for the movie Oz, and it was a Google project, oddly enough. Well, actually, no, it's not a Google project. It was just Google used it as an example on how powerful the Chrome browser could be. So in Find Your Way to Oz, this was a project created by Disney working with a bunch of other agencies, and it actually uses the Get User Media API that I referred to earlier in this presentation. So there's this photo booth, 3D photo booth, and you can actually take your picture and it'll like do some crazy stuff to your photo. So consider Three.js as a toolbox. So think of P5.js as like a simple pencil, Three.js as a toolbox for 3D using JavaScript. You have methods for generating geometry, so you can use Three.js to create cubes, since we're working in 3D, spheres. There's also ways for you to import meshes from 3D applications. So if you're using things like Maya 3D or AutoCAD, you can save object files and bring them into your JavaScript code using Three.js. Lighting. So there is a bunch of lights provided by Three.js. You have directional lights, spotlights, ambient lighting, animation methods. Post-processing is fun. Post-processing. So think of post-processing as Instagram filters for your 3D animation. So let's create a cube. This very unassuming 3D cube. So in our initialize method, we're initializing the renderer that will draw these pixels to the screen. We're saying the pixel ratio So here, if you're viewing, you can also set this dynamically so you could have other logic that detects the pixel density of the screen and then accommodate, saying the size of our 3D animation and scene. So you can have multiple scenes. So you can have like a cube and then have another scene with a different kind of cube and then link them together. Then we want to create our camera, so we have a perspective camera here that's just sitting there looking at the cube. We're going to actually create our cube. So there is a box geometry method, 200 pixels wide, 200 pixels tall, 200 pixels deep. Texture, we're passing in a GIF. Then material. So what material does is basically, this is what this material does. Oh, how the light reflects off of your texture. Bumpy, smooth, etc. Then we're combining these using the mesh. So the geometry actually just stores a bunch of coordinates in three-dimensional space, and the mesh method ties that to the material. Then we're adding our mesh to the scene. Then we're animating our cube. Now, this looks familiar, doesn't it? We've just used in like 2 out of 3 frameworks. So request animation frame. During each animation loop, we're subtly rotating the cube along the X and Y axes. Now I'm just gonna go over beauty breakout. So here I'm initializing several lights. Now I'm not actually using, it's a very complicated method. Well, so what's happening in this method is like I'm spitting out 3 different spotlights, but all those spotlights are of a different color. So if a red spotlight kind of crosses paths with a yellow spotlight, it creates this nice purpley hue. So that's what this method does, just generating different spotlights of different colors. Then I'm creating a reflection. A reflection is not actually happening. What we're doing is we're wrapping the shapes that are being generated, and we're putting them in a big cube that you can't see. So they're inside this cube, and along the walls of this cube are textures. And so we're telling THREE.JS, hey, if an object is facing this side of the cube, that object should have the same texture as that cube. And that kind of creates a fake reflection effect. Here we're setting how light reflects off of that material, the shininess. Then we're generating mirror pieces. So I'm actually using a different JavaScript library to create Voronoi shapes. And then I'm passing in those so this other JavaScript library just spits out an array of objects and these objects have coordinates in 2-dimensional space. So I'm passing in this array into THREE.JS and I'm telling THREE.JS to extrude it. So kind of raise this 2-dimensional space and bring it out into 3-dimensional space. So this is the actual sketch. This GIF is like 5 megabytes. Notice this very, very subtle reflection and the color changing kind of. Shaders. So shaders are, I would say, not quite machine code, but shaders are code is code that directly talks to your graphics card, I think is a way of describing it. So here we have a water effect that's entirely created by a shader, and you can pass this code into THREE.JS. Here's another shader. So you can initialize a shader in a post-processing method that THREE.JS provides. So notice how it's all pixelated. Potential hiccups. One thing when you're first starting out with THREE.JS is like, why can't I see anything on my screen? There's no camera. You forgot to put a camera in that environment, so obviously you can't see anything. No lighting, it's too dark. Wrong zoom level. So you're either zoomed in too far away that your object is like so tiny, or you're zoomed in so close that the screen is just like this weird color. Or you have a weak GPU. This is a problem with THREE.JS. If you have a very involved THREE.JS animation, but your user's computer just doesn't have a powerful enough graphics card, they will not be able to run your code. When not to use JavaScript. JavaScript is great for a lot of things, but sometimes you simply don't need it. Simple animations could be done with CSS3. So the drawing circle that we've been drawing repeatedly, we can actually accomplish with just straight up CSS. So there's this animate function, and what you pass into this animate function is this move property. So here it's like, once we reach 50% of the animation, do this transformation to our circle. Performance is a concern. So if you're using RAPHAEL.JS and you're doing a bunch of stuff, like you want to draw multiple circles and you want to animate it all over the place, your browser will slow down. Canvas element keeps everything in memory. Responsive design with JavaScript drawing requires investment. So in numerous examples, we've explicitly set the width and height of the area which we're drawing to. If you're unwilling to figure out how to dynamically set that according to what device the user is doing, your JavaScript drawing project will fall flat. THREE.JS might not even run on a lot of Android phones because some phones might not have a powerful graphics unit in them. So only do responsive JavaScript drawings if you're willing to put in the investment. Conclusion. JavaScript, more than one way to do something. We see this in the MVC framework world. There are like how many MVC frameworks? Probably more than we care to learn. And we see this in drawing too. You can draw, we drew that circle 3 different times. But what you can also, we drew that circle like 3 different times. To create data visualizations, you don't necessarily need to use D3.js. You can go back to using P5 or RAPHAEL or even 3.js to do some kind of like 3D generated bar graph. You can also use P5.js for 3D. I think they're working on it, but with processing, you can set the canvas to be a 3-dimensional canvas, and you'll be able to do that with P5.js down the line. So don't attempt to make another framework, because there are already there are multiple ways to do the same number of things. Unless you really need to, or it's an academic exercise. You may think your project is very domain specific, and you want to create your own framework because you're thinking, oh, P5.js can't handle, or D3.js can't handle what I want to do. It probably means you didn't do your due diligence to research. And you don't want to underestimate the time it takes to create a framework. 3.js, P5.js, and D3.js are all actually open source initiatives, so all their code is on GitHub. However, building a framework is like building your own tools to help you, and when you build your own framework, you gain appreciation for existing tools. You could build another framework on top of D3 or 3.js to do what you want it to do. if you find that if you can't figure out how exactly to hammer those frameworks into doing what you want to do. So now that you have the tools, or you know of the tools, so why don't you go out and draw and animate? So thanks for listening to me. If there are any questions, we'll take them. Yes?
Yeah, you mentioned about how THREE.JS will work on Android phones or with GT like it do. Does HTML5 have a way so that you can ask it if you run this WebGL stuff, or do you just have to like try it out there?
I think you have to try it. You can do something where you detect whether or not the browser can run Canvas using WebGL. You could also write a script that runs a very simple 3D animation and then track the frame rate that the user's browser is spitting out. So the ideal frame rate is 60 frames per second. So you could just have a small testing animation running, and if it just that runs for maybe a few seconds, but then you have like a loading issue. You're making a user load. I mean, that's the problem with Three.js, is that there's a lot of preloading going on. Like for example, Beauty Breakout, it's doing all these calculations and it takes like 1 or 2 seconds to load it. It doesn't sound like a lot, but when a user is browsing the internet, they expect things to just happen really quickly. Any other questions? Go ahead.
Is there something I imagine either built on top of D3 or something D3 can do where you just say, I have this HTML table, and you just give me a bar chart or whatever of this table quickly.
Yeah, I'm sure there's something, if you just Google it, there's like so many people have like, oh, here's a super simple framework for doing a bar graph or a line chart. But then if you dive into it, they're actually using D3 for all the heavy work. Could I get a sense of the room? Like, how many people work at like an advertising agency where they have to do some product pages? No. So using JavaScript to like do the whiz-bang stuff that your clients want is probably a good idea, because then you reduce technical debt and the timelines are always shorter than you want them to be. And you don't have to hire like an ActionScript developer. Any like 3D hobbyists, like people who just play around with 3D applications? You could probably do a lot of stuff with Three.js, like if you just import your models and stuff. I'm really sorry the internet's not working. These are really cool demos.
It might work now, it's reconnected.
Yes. Another question is whether or not this laptop could handle it. It's not handling it. So it's not running the shader that actually generates the ocean. But we do have this nice spear that's dipping up and down into this black ocean. Oh, there it goes. So that's all happening in the browser without any plugins. So here is the code. So the shader is actually over here somewhere. Fragment shader. So fragment and vertex shaders are two different kinds of OpenGL file formats. A fragment shader is used primarily to manipulate pixel data, so the color of a pixel. Vertex shader is for geometry, so shapes in three-dimensional space. What are the cool examples that I want to show? Okay. So here we have a mirror that's being generated using box geometry, I think. But when I click, I have some code running really quickly to generate these cell shapes. So notice how the color is kind of changing. That is because I have 3 different lights spinning around the space. Wow, we're really holding at 60 frames per second. And so during each animation loop, each piece has its own coordinate it's trying to reach, which is randomly generated at the app initialization. And so as the animation runs, the piece is flying out into space, seeking out this randomly generated 3D point. And once it reaches its target, it triggers a bounce animation. And so once that bounce animation is triggered, it's going back to the origin, which is 0, 0, 0.
Can I just ask,
Sure.
did you use the second library for that?
Yes.
What was the name of that?
It's if you Google Voronoi library, VORONOI, it'll probably turn up.
Right, okay.
Can you suggest any good resources for sort of inspiration for taking boring data and visualizing it in an interesting way?
Oh yeah, if you go to the D3 website, there's so many examples. It's assuming we can load. Whoa. So that animation we saw is, this is, I think, is a forced layout, which is included in D3.js. So all you have to do is put in the data and make sure the data points have color to them so they're not invisible. The Guardian is doing a lot of data visualization work, as is the New York Times. They're doing more and more of that stuff. This isn't data visualization, but as you move around, this is done with D3. It's just dividing the circle more and more and more and more. So let's view page source. I was just trying to look at the dynamically generated DOM. Oops. This is going to take forever. So while it's loading, it's probably loading all of the shapes. So each shape in THREE.JS is just like an object of coordinates in 3D space. So if you're having speed issues with THREE.JS, one way you can make it faster is just to simplify your shape. So remove like a vertex from like a rock or something. What is this? So this is all THREE.JS. So there's a lot of stuff going on. We have trees, textures, lighting effects, lots and lots of textures. Textures could also be a way where you can cut the fat. Just poor quality textures if you find that your THREE.JS animation is running really slowly. I doubt I can run the photo booth because this computer does not have yet. So here it's using JavaScript to detect whether or not you have a webcam, and if you did, it would ask you for your permission, whether or not I could access it. Let's see. Was there an example that someone wanted to see that I couldn't? Damn it. Any more questions? This is using JavaScript to animate, by the way. I'm showing. So, yep, canvas element right here. So notice that we don't see a DOM element for the dinosaur and the cactus. It's all stored in somewhere in the canvas element. So it makes it very hard to debug, but I think in the next version of Chrome DevTools, there are going to be debugging tools for debugging your canvas animations and drawings. Any other questions? So I'm compiling a list of references. So websites I use to like create this talk and stuff. So you like tweet at me. I'm probably gonna tweet it out. So if you want more information, my slides are also online, and I'm gonna tweet that out soon. Thanks for listening to me.